Hello, and welcome to the section about tower checks. And the learning objectives for this video on tower checks are going to be first, to understand a more detailed version of the tower forces, specifically on the tower columns and the walkway hump. Second, be able to apply these advanced checks to the standard tower details. Third, analyze if tower analysis for your custom design will govern the design. And fourth, be able to apply engineering judgment for evaluating the tower details. Now, in the basic design course, we only considered the entire tower and tier assembly for overturning. You can see here I've drawn out and separated each item, the tower columns in gold, the walkway hump in magenta, and the tiers and foundation in blue. And like I mentioned, in the basic course, we are just looking at this red point where there is an overturning moment and a restorative moment due to both the self-weights of these components and the cable forces, which I've also drawn here in red. However, there is no tension connection using rebar that is keeping the tower elements from separating at its toe at the top tier. So that is this point, I've drawn in red, toe of the tower. And likewise between the tiers. So these elements are only connected through just their center of masses being offset, so their self-weights and the friction by that. And you can see here on the right, the CM1, CM2, CM3 example I've drawn showing the offset centers of mass that result in that restorative moment that we were talking about for the basic design course. And on the left again, you can see how there is steel rebar. If you can confirm this if you look at the standard tower details. There's steel rebar that comes down from the tower column into the walkway hump, but there is no connection at the joint into the tiers. And this will be the motivation for a lot of our tower checks. So in addition to doing this overturning check that we do in the basic course, which is still important, we also need to evaluate the overturning at the tower, which, as you may remember, is the combination of the two tower columns and a walkway hump. So for terminology moving forward, like I mentioned, we'll have two of these tower columns, and we'll have one walkway hump, and we'll call that our tower assembly. Not to be confused with the basic course, which refers to the tower assembly as the entire structure, that is the towers, the walkway hump, and the tiers and foundation. So we're just referring to those two tower columns and that one walkway hump that you can see in the standard tower details. So our first check will be overturning at this red point, the toe of the tower. And this check goes hand in hand with checking the eccentricity of the resultant cable load on the tower. So this is also not to be confused with when we refer to an eccentric load as where its placement is and how that can cause a moment because it's not placed exactly at the center of gravity. The eccentricity in this case is going to be the location of the resultant, which depends on the magnitude of the horizontal force from the handrail cable and the vertical force from the handrail cable. So don't worry about this too much. We'll go into more detail when we talk about the specific check. We also need to evaluate the internal stresses in the tower columns for adequacy. So we'll do this by first checking its flexural capacity as a cantilevered beam and the cracking moment for serviceability. So we'll check the tower as a beam, we're going to check its flexural capacity, and we're going to make sure it's not going to be cracking, which will let water into the tower and corrode the steel that is inside. Finally, we'll check its biaxial capacity as an eccentrically loaded beam column. Now that is quite the mouthful, but hang tight and we'll talk about that in the last couple sections of the video. In this case, we're looking at both the column acting as a cantilevered beam and the axial load that is put on the column from the cable forces and how these two combine and what sort of forces and that can cause and how we check that.